This is a prototype model of the F-102A, the Air Force's first supersonic all-weather interceptor. It is a one-man aircraft capable of operating at speeds up to Mach 1.2 and at altitudes from sea level to 55,000 feet. It is equipped with the MG-10 aircraft and weapon control system and armed with 2.75-inch air-to-air rockets and Falcon air-to-air guided missiles. The Falcon, a supersonic seeker missile, gives the F-102A a marked advantage over any bomber. For with Falcons, the interceptor can attack from well beyond the range of the bomber's defensive armament for all directions of attack, and the Falcon has a high probability of striking the bomber despite any evasive maneuvers. The F-102A carries two types of Falcons, the GAR-1 and GAR-1B. The GAR-1 is a semi-active radar seeker. That is, it homes on the echo from a target illuminated by the fire control radar carried in the interceptor. The GAR-1B is a passive infrared seeker. It homes on the infrared radiation from the target. Together, the radar and infrared Falcons are complementary weapons which, in a mixed load, make possible missile attacks under nearly all attack conditions. The MG-10 system is a radar, computing, and control system that enables the pilot of the F-102A to locate his target at long ranges, to attack it effectively, and to return safely to base after the attack. During the approach to the target, the MG-10 system performs two primary functions. First, it automatically receives, by coded radio transmission from the GCI station, data on where the target is and how to steer to intercept it. Second, the MG-10 system automatically searches for the target by radar. When the pilot has located the target and locked the MG-10 radar onto it, the MG-10 system automatically flies the interceptor on a correct attack course for the selected armament and fires the armament at the correct time. In addition to these primary functions, the MG-10 system has three types of secondary functions, which may be useful either during the approach to the target or the return to base. First, the system provides a mode of operation called snake for following another interceptor accurately and safely under conditions of poor visibility, or for approaching an unknown aircraft slowly from the rear so that it may be identified visually. Second, as an aid to navigation, the system's radar may be used for ground mapping or for taking fixes on radar navigational beacons. Third, the system's flight control equipment may be used to perform the pilot assist functions of maintaining the interceptor's bank attitude or heading and its pitch or altitude. Or it may be used for flying the interceptor automatically during ILS landing approaches to the point of flare-out. The MG-10 system consists of 6 major functional elements: a radar, a data link receiver, a computer, an automatic flight control system, missile auxiliaries, and an optical sight. The radar performs automatic searching, automatic tracking, beacon interrogation, and ground mapping. The targets picked up by the radar are presented to the pilot on a scope in a B display. That is, each target appears as a blip of light whose vertical distance from the bottom of the scope represents the target's range, and whose horizontal position from the center of the scope represents the target's azimuth. The data link receiver receives coded radio transmissions from the GCI station and automatically processes them for display to the pilot. An automatic data link has the advantage over the usual radio voice communications of having a large capacity, a high reliability of data transfer, and a low susceptibility to enemy countermeasures. The data received by the data link consists of target range and bearing, which are indicated on the radar display by a small target marker circle, heading for the interceptor to fly, which is indicated by the lateral position of a steering dot, time to go to destination, which is indicated by the diameter of a circle, and the target's altitude, which is indicated by a meter on the instrument panel. The computer performs the interceptor's fire control computation. Once the radar has been locked on the target to be attacked, it supplies the computer with the range, angular position, and angular rate of the target. The computer then computes steering instructions for directing the interceptor on the correct attack course for the selected armament and generates pre-launch sequencing and firing signals for the armament. The steering instructions are fed to the automatic flight control system and to the radar scope, where they are used to position the steering dot. The sequencing signals are fed to the missile auxiliaries. The automatic flight control system may or may not be used at the discretion of the pilot. It has 3 modes of operation: attack, pilot assist, and AILAS. In the attack mode, it steers the interceptor precisely in accordance with the steering signals generated by the computer. In the pilot assist mode, it maintains the attitude of the interceptor in accordance with the setting of controls in the cockpit. In the AILAS mode, the automatic flight control system flies the interceptor along the landing approach course in accordance with information received from the ILS receivers. The missile auxiliaries prepare the Falcon missiles for launching. Upon receiving sequencing signals from the computer, they supply pre-launch warm-up power, adjust the sensitivity of the missile's internal control systems for the altitude and closing rate of the particular attack, specify the target to the missiles, that is, make them look in the right direction to see the target, and in the case of the radar seeker missiles, synchronize the radar receivers in the missiles with the fire control radar. The optical sight is provided for use in the event that radar operation is impaired, which it might be as a result of enemy jamming or excessive ground clutter. The sight enables the pilot to make visual attacks with either his GAR-1B infrared seeker missiles or his rockets. The MG-10 system may be supplemented with an air-to-air IFF system called the APX 26 and 27 Fighter Identification System. If included, this equipment will enable the pilot to determine whether the targets displayed on the radar scope are friendly or enemy. Having seen what the MG-10 system consists of, let's take a quick look at the installation of a prototype system in a F-102 aircraft. The bulk of the MG-10 system is installed in the nose section. In the cockpit, the principal components and controls are the radar scope, the radar hand control, which is the left-hand grip of a newly developed dual-grip flight stick, control panels for the radar, the data link, the automatic flight control system, and the fighter identification system, and the optical sight, which in production aircraft will be mounted on the canopy. To see how the MG-10 system operates, let's follow the interceptor on a demonstrational mission in which the pilot will try each of the system's modes of operation, making dry run attacks against another aircraft. During the first part of this mission, the interceptor will be flown very much as it would be during a tactical mission. By means of the automatic data link, GCI will direct it onto a collision course with a moving offset point from which the interceptor can attack the target most effectively. When the interceptor reaches the offset point, GCI will direct it approximately onto a collision course with the target. The interceptor will follow this course until it picks up the target with its own radar. We're at altitude now, and the MG-10 radar is searching for the target. On the scope, the range trace sweeps back and forth in synchronism with the search scan of the radar antenna. The broken horizontal line is an artificial horizon. A circle is visible in the upper left-hand corner of the scope. This circle is the target marker. It is positioned in accordance with data received from GCI by the data link receiver and indicates where on the scope to look for the target. By restricting the area in which the pilot has to look for the target blip, this marker will greatly increase his chance of picking up the target at long ranges. Only a portion of the circle is visible now because the target is beyond the range of the display. The dot on the center line of the scope is positioned by the azimuth steering instructions received from GCI. The dot is now on the left side of the scope, indicating that the pilot must turn to the left. As he does, the dot moves to the center of the scope. Centering the dot puts the interceptor on a collision course in azimuth with the moving offset point from which the pilot is to start his attack run. The pilot flies to the right altitude for attacking the target by comparing his own altitude with the altitude of the target, as received from GCI and indicated on the meter. If the data link is jammed, the pilot is warned by disappearance of the target marker circle. While the jamming persists, the steering dot continues to indicate the last instructions received from GCI. When the jamming stops, the target marker reappears. About 2 minutes before the interceptor reaches the offset point, a large circle appears on the scope. It is called the time to go circle and indicates by its diameter the time remaining until the offset point is reached. When the offset point is reached, the time to go circle disappears, and the dot moves out of the center of the scope, indicating that GCI is sending different heading information. Centering the dot now puts the interceptor roughly on a collision course with the target. To the right of the circle, a blip is beginning to appear. This is probably produced by the target's escort plane. Inside the circle, the target blip appears. For this demonstration, the escort plane has been equipped with a transponder for the fighter identification system, as all friendly aircraft normally would be, whereas the target has not. The pilot now interrogates both aircraft by pushing a switch. The blip to the right of the circle disappears, indicating that it is friendly. If the blips are weak or fading badly, the pilot can check the identification by pushing the identification switch in the opposite direction. Then, the blip from the friendly aircraft is intensified. At this point, the pilot would normally select his armament. The choice of armament depends on the loading of the interceptor. A typical loading might provide the pilot a choice for radar attacks of 3 radar missiles, or 3 infrared missiles, or all 6 missiles, or 24 rockets. For optical attacks, that is, attacks in which the optical sight is used, the pilot would have a choice of 3 infrared missiles or 24 rockets. For this demonstration, the pilot's first dry run pass at the target will be a radar run for firing missiles. Since no missiles were loaded, the annunciator reads no. To initiate the attack, the pilot locks the radar on the target. To do this, he takes control of the radar antenna with the left-hand grip of the dual-grip control stick, moves the grip sideways to align the range trace with the target blip, adjusts the elevation position of the antenna with the thumb-operated knob to get the brightest blip, then moves the grip forward to align the range mark with the target. When the radar is locked on the target, 3 changes occur. The target marker circle disappears, the steering dot moves out of the center of the scope, and two concentric circles appear. Centering the dot will now put the interceptor on a lead collision course with the target. The inner circle is a reference for centering the dot. The outer circle is a range circle. Once the target's range has reduced to 25,000 yards, the range circle will shrink so as to indicate by its radius the range of the target. The position of the gap in the range circle indicates closing rate, which is read in hundreds of knots from the scale on the rim of the display. At the time of lock-on, the pilot engages the automatic flight control system by releasing the control stick. The system then automatically steers the aircraft so as to center the steering dot. As the time to firing diminishes, the reference circle suddenly shrinks. At firing, which is done automatically by the MG-10 system, the two circles and steering dot disappear and an X appears. The pilot takes control of the interceptor manually and breaks off the attack. It should be pointed out that approximately 16 seconds are required for preparing the missiles for launching. If the pilot is locked on so late that there is not time for this, he will get the pull-out signal without missile firing and must break off the attack and make another pass. The pilot will now make a radar run for rocket firing. The radar rocket attack is very similar to the radar missile attack. As soon as the radar has been locked on the target, the pilot releases the stick and the automatic flight control system takes over. Notice how rapidly the system brings the interceptor on course. The pilot monitors the system's performance by watching the scope display, and he can, at any time, take control himself merely by grabbing the stick. The pilot next will demonstrate the system's optical mode, first for firing infrared seeker missiles, then for firing rockets. For firing infrared missiles, the optical sight directs the pilot on a pure pursuit course. That is, the reticle of the optical sight remains centered. As soon as the pilot has located his target and gotten into position for attacking it, he partially depresses the trigger to a detent position. This starts the pre-launch preparation of the infrared missile. And when the target is centered and its wings fill the inner circle, the pilot depresses the trigger all the way to fire the missiles. For firing rockets, the optical sight directs the pilot on a lead pursuit course. The pilot flies to keep the reticle on the target, and in response to the turning of the interceptor, the reticle is displaced to indicate the correct lead angle. When the target's wings fill the outer circle, he fires the rockets. Now you have seen the MG-10 system in each of its primary modes of operation. On the way back to base, the pilot will demonstrate the system's secondary modes of operation. First, he will try a snake operation. For this, he locks the radar on the aircraft to be followed, then steers to center the steering dot on the scope. By flying so as to keep the range circle at the right radius and the closing rate gap zeroed, the pilot can follow the other aircraft accurately and safely at any desired interval. For the benefit of the aircraft ahead, the interceptor's armament is disabled during snake operation. The two radar navigational modes are about the same as in previous fire control systems. Here is beacon interrogation. The two horizontal strobes bracket the 20-mile range segment that will be expanded. This is ground mapping. Here, the map is expanded. The pilot assist mode of automatic flight control is engaged whenever the pilot releases the flight stick, provided the flight control system is on and the radar is not locked on a target. When engaged, the system holds the interceptor in whatever bank and pitch attitude the interceptor was in when the pilot released the stick. If the pilot wishes, he can, by throwing a switch, cause the system to hold the interceptor's altitude instead of its pitch attitude. If the interceptor's bank angle is less than about 10 degrees, depending on its speed, the automatic flight control system will level the interceptor's wings and maintain heading instead of bank attitude when the pilot releases the stick. If the automatic flight control system is switched to the automatic ILS mode, it will fly the interceptor automatically on an instrument landing approach. With its MG-10 system and its Falcon missiles, the F-102 will be a major weapon for air defense.